Welcome guys. Okay, so today we are trying to prove these three tangent integration. So these three are very common. Basically, yeah. Okay, so the first one we already before I start, please leave a comment and subscribe to my channel or click the like button. Okay, so in the beginning, we already proved this in my other videos, so I will just quickly mention. So one can just write tangent ax as sine ax divided by cosine ax, and this sine ax is the dx cosine ax minus cosine ax. So when you do the cosine, you get minus sign, right? So there's more minus a here. So this is cosine ax plus c. Okay, so this is correct. Okay, and this one is just secant square x minus 1 dx. And we know that there's a formula. Basically, if you differentiate respect to tangent x, then you get the seconds. Right, so basically this is secant square x minus 1. Right. So dx minus dx, because this is tangent x minus x plus c. Okay, so these two I think is trivial. Okay, so the next one is this one. So what I want to do in the next page is basically prove this somehow difficult one. So there's a here. Okay, so a is like a non-zero real numbers. Okay, so one idea is that it's very easy to guess. Is I just write it as tangent square ax dx, and I can write it as tangent minus 2ax secant square ax minus 1 dx. So the first one is just tangent minus 1 to ax secant square ax dx minus tangent minus 2ax dx minus 2 power. So just expand it, and this is the tangent ax divided by 1 over a. So we use the integration by part. So this is tangent minus 2ax 1 over a tangent ax minus a tangent ax, and the differentiation respect to x, right? So you get a here, and you get secant square ax. So you see you always get another secant square, and then this is a minus 2 tangent a minus 3 let me see. Okay, so ax. Okay, and so this a cancel. Oh, sorry about this. What I'm writing about this a cancel. Minus tangent minus 2ax dx. Okay. So remember this is the left hand side. Okay, so it looks like that we have the similar term, right? But we need to somehow like change the rest of this term, right? So can we just see carefully what is it? So this is tangent minus 2ax a minus right. So this is tangent minus 2ax, and the second, right? So secant square, right? So secant square is tangent square ax plus 1 minus dx minus tangent minus 2ax dx, and then this is tangent to nax dx. Okay, so if we see carefully, we see this term is exactly this. Oh, there's still a minus 2 here. Yeah, we need to be careful. So there's a minus 2 here, right? So this term can be combined with the left hand side. Hopefully we can get it right. So this is 1 over a tangent and minus 1 ax. So we combine these term, and there's a rest of a minus 2 term, but there's a there's another term here, right? So you get what? You get the minus. You get minus 2 of this tangent of x. Minus is tangent n to the power 2 of ax. So you see, you can combine these two, right? You combine these two, so you get the minus and minus 2 minus 1, right? And so this is this term, and with this dx. Okay, and then we divide it by n minus 1 from both sides, so we get this. So somehow like we already somehow like we recover the first term, 1 over a n minus 1 tangent ax, and then this is minus n plus 2 minus 1. So this is just minus n plus 1. So this cancelled. There's a minus sign here. So you get the tangent n minus 1 ax divided by a n minus 1 minus tangent n minus 2 ax dx. Okay, so this is the formula for this proof. Okay, so I will see you guys in the next videos. Be sure to subscribe to my other channel. Thanks.